Okay, testing again. Okay. I don't know. Let's just get it ready. What? Okay. Yeah, doesn't seem so super slow. I will just prepare a few more things I forgot to prepare. No. Okay. Okay. Yeah. Not that. Okay, we have 2 minutes to start. So far, only 2 people, including, yeah, that's me. So 1 people watching the stream. I mean 1 human. And I guess we are waiting for others. Yeah. Okay, so this should be. Let's go over. Okay. I forgot to edit some things. The latest version is 365. Where is it? 36. Yeah. 5. I guess. Let's build it again. So probably we should yeah. Also again, just going quickly through this. Yeah. Should update that. No, it's too slow. Yeah, so topic. How do I do it? Okay. So if anyone is watching, please write on the IRC so I know how much people are there. Looks yeah. So the link is it's not so slow. It's sort of good. Stream this link. Okay, let's do it like this. Actual class. I'm not sure what the topic was before. Yeah. Streaming now. Yeah. And this. So this should work. But did it work? Yeah, I guess. Okay, who is watching? Please write on the IRC. I expected more people. Okay. Okay, let's give it 3 more minutes to let others join. If someone is late, I will ping on. I'll just show it. IRC. Is everybody? Come and join. Yeah. Link is in the pick up our print up classroom. I'm in work, so I hope not so much people will bother me during the next 2 hours. We will have some breaks during the whole thing, to ask questions, to give a breather, everything. So I will just few more minutes. Still only one watching. That's nice. Anyways, this will be recorded, so as at least people can use it. I will cut it after this intro. I will just prepare a few more things in here, actually, in this IPython notebook, which is the same thing as the GitHub for Python beginners is. We will have the same IPython notebooks, which is sort of like, well, this is just a JSON file with lots of cells in it. Who is highlighting? Nobody watching my. I mean, one person. Sorry. Okay. 15. And switch it here. Never mind. Okay, nobody can see my address now. Okay, so let's see what I wrote here last. Jeez, what is this? Okay. Yeah, I guess it's good. We will have boolean and stuff. Okay, it's 9:05, so it's time to start officially. So let's get started. Let's just, okay, starting now. So, full screen, hide this. So Python 01, like this is the first intro, which I will show you why Python, what is it about, and the intro for this whole course. So, what is Python? Python is widely used high-level programming language for general purpose programming. It's open source and community-based development model. So it was started by this guy, Guido van Rossum, and was named after the Monty Python show, which all of you know, these guys. And you might remember this logo with snake. I think it's used for Python 2 in some cases. Python 3 logo looks like this now. But just to note that the name is based on the show, not some snake. There is not just a single developer. There are many core developers, at least dozens. So they are all contributing to the language. So this guy is not making everything. There are like, dozens of people. They are talking in PyCons, which I will have link for. Very interesting sessions to watch. So that is Python, widely used high programming language. So why Python? It's beginner friendly, and it was designed to be easy to understand and fun to use, just like Monty Python. Someone is late. no worries. So it's, as I said, it's high-level language which reads like English. So as you will see the code, you will sort of understand that what's the code doing. I mean, after some practice. So you shouldn't like dig too much what is the code doing. You should have it at first look if it's well written, that is. So it handles also lots of complexity for you, so you don't have to deal with too much issues that is already resolved by other people. So we just use some general guidelines for, let's say, opening and writing files, and you don't have to deal with extra details. Of course you can if you want, but the idea is that you don't have to. And the language is also very flexible, so no hard rules to follow. There are just some coding standards like PEP8, which I will link later. And yeah, I mean, if you are working in a team, you probably have some code standards, what to do, what not to do, what functions, what kind of way you want to be programming. But in general, if you are just writing the the Python program yourself, you can do anything. It's highly portable, the Python language. It can run almost anywhere, so you can run it on phone, on 60-bit, 32-bit. Yeah, ARM is phone, but it's kinda, well, I'm not sure. I think it converts to, I mean, at least on Android it converts somehow to Java. But anyways, there is like MicroPython, which is like very small electronic device, which can just run on battery, and that runs quite well. You can do some home automation with it, so sort of like a Raspberry Pi, just with Python, just pure Python, no OS there. The community is very large. It's a popular and discussed language. We will show some popularity graphs later. And there are PyCons all over the world. So here in Czech Republic there was PyCon just last summer. I mean by beginning of the June. In America, in China, Russia, all over the world. You can find many good talks on YouTube and other links. And for example, in Czech Republic we also have like some local meetups, Pivo and stuff. So, and future, this is open source project, so if something bad is gonna happen to part of the developers, they are going to, others going to take over, and the language will just not simply die. It will continue somehow. And latest version is Python 3.6.5 with thousands of modules. There are many third-party libraries, like over 100,000. Some of them, I mean, they're third-party because they are not in the standard library. For example, like requests module. So, but it's easy to install these third-party libraries. There is also Python 2, 2.7 something, but that will be discontinued by 2020. So, I mean, the Python 2 and Python 3, at least some time ago, were released together, but Python 2 is just, maintained, so it has all the security patches and stuff, but it will not be followed. I mean, it will not be supported after 2020. We will show a link for the clock down, time down. So we can go to design philosophy. I will just have a look at the question. That was not Beatles, that was Monty Python. So I will just click query apply. Meanwhile, you can read this XKCD comic. That was Monty Python. Okay. I cannot write. Monty Python. So I will just read it aloud, so if you cannot see it. So there's this guy on the ground saying, "You're flying, how?" On the other guy who is flying. He says Python, he or she. I ran it last night, everything is so simple. Hello world is just print, hello world. So this is actually a good point. There are no parentheses around the print, so this only works in Python 2. In Python 3 you have to have parentheses around after the print, because it's a function. In Python 2 it was still a statement. So they continue. The dynamic typing, white space. So the guy is worried about many people are worried about the dynamic type language. It's not static type as other languages. And white spaces and tabs, it might not seem very nice to some people, but the other guy says, come join us, programming is fun again, it's a whole new world up here. And he asks, but how are you flying? I just typed import gravity, that's it. I almost sampled everything in the medicine cabinet for comparison, but I think it is the Python. So that's one of the jokes for the for what Python does without you knowing. I guess it was meant like that. Never mind, let's continue. So as you saw there, if you write import gravity, it does something. So import anti-gravity. So if you do import this, it also writes something. So you can actually try it. Python. So this is 365. We can see Python 2. Yeah, that is 2 to the 17. Anyways, it works in both. So this is just a version of Python. I think it's one of the PEPs, and this is very interesting. What these say, but yeah, let's go over it. So it's like I guess you can compare it to 10 Commandments. So this is like stuff, sentences you might recall while programming. So just to explain a few of them, many will, they will make sense after you do some coding. So beautiful is better than ugly. So that relates to the readability. The nice Python code should be sort of beautiful, so it reads nice. Explicit is better than implicit. So there are many ways how you can write some code, and you can either do it like hard to read, so the things are not clear at first look, or you can do like very verbose, so there is no way for error. So that's kind of like the explicit way. So, and someone not really known in the problematics of some specific library can just read the code, and when it's very explicit, it will be easier to understand. Simple is better than complex. So you can try to doing things simple and not just complex. I don't have any example for this, but you will see in some cases you will understand. And complex is better than complicated. So of course you will find some issues that are just cannot be done simple way, or are just too complex, some rocket science. So there is still way how to do it complex and sort of simple but not too complicated. Well, again, no example, but you will get the idea one day. Flat is better than nested. So you might recall some JSONs and they go deep, and there is like key inside the key, and inside the key is another key, and it's very, very deep, and then it's harder to work with. So you can do it flat, which is easier to work with. I guess that's an ideal example. Sparse is better than dense. So again, less is more. Keep it simple. So again, the same example. that leads to readability counts. So all of these points up, they could relate to readability counts. Yeah, because if you are maintaining some code after a colleague or anyone else, you just want to have things simple and not too much complex, too much lines, when in the end it would do the same thing. So special cases aren't special enough to break the rules. So you have some rules, the coding standards, the PEP8, some common sense when you are writing program, and you might hit some special cases. So you should try to not break the rules, but just to make it fit somehow, to be simple and flat and sparse and explicit. But the next sentence says that if it's something very complex, you don't have to make it too pure to follow these laws, recommendations too much. So you just make it practical, but out of the rules. So just, again, common sense. Errors should never pass silently. So when we will come to the point when we will use try and except, that means when there is some code that has chance to fail, or some function, it will raise a code, and we should never. There is a way how to silently ignore the errors, but that's a pathway to hell, because you should catch all errors and act accordingly, so you don't have the debugging mess. Yes, that's PEP 20. Thanks, the Zen of Python. Okay, errors should never pass silently unless explicitly silenced. So that's the rule. There might be some cases like warnings. Let's say you are doing some HTTP requests and there is just some warning which doesn't break the functionality. So you don't want to bother a user with that. Oh, there is an error. Look out! If you are sure that it's just a warning and it will not affect the functionality, you can silently, just silence that kind of error. And we continue to the rest of it. So in the face of ambiguity, refuse the temptation to guess. So if you are not sure what is like your design, don't guess. Just stop and try to work it out. Although there might be cases when you are learning something, so it's just trial and error. So at least in cases when you are not moving with files too much. Oh, stream is not okay. Let's check. Yeah, it's sort of so we have an issue with the streaming. Okay, good. Okay, probably overloaded network. The streaming is not so easy. Where were we? Here. And also the PC is kinda lagging, but yeah, that's okay. No. Okay, so let's continue. So there should be one, and preferably only one, obvious way to do it. Come on, let's do full screen. Yeah. So yeah, if you have some issue, you probably there is just one obvious way how to do it, and just general recommended way, what most people can agree on. So you should, if you are not sure about it, you can ask people and they will probably lead you that way. And that is a joke. This thing, although that way may not be obvious at first unless you are Dutch. So the guy van Rossum is Dutch, so Dutch are considered very good in IT in general, I think. So if you are Dutch, you are just okay. If you are not Dutch, you just have to ask people and think more. Okay, now it's better than never. So I guess that this relates to if you find some issue in the code, you can like fix it now, or you know, if you don't, it might come haunting you later. But again, although never is often better than right now. So you know, I guess this relates to that kind of thing, that when it's not too much too much work at the current time, you can just leave it later, but make it visible so we don't forget the bug. So now the last three: if the implementation is hard to explain, it's a bad idea. So if you are talking to someone about the implementation you want to do and it's hard to explain, it's probably a bad idea, because it's hard to understand. But on the other hand, if the implementation is easy to explain, it may be a good idea. So because as you are programming, you are telling computer what you want to do, and if it's hard to explain, it will be hard to write. If it's easy, it will be easier. So I keep that in mind. And namespaces are one honking right idea. Let's do more of those. So we will see that there are lots of names in Python, and they make a lot of sense. So as you will name variables and functions and all of those, you can just name it nicely in some code standards way, like classes start with a capital letter. Camel case is not used too much, but in some cases it might be useful. And etc. Just there is lots of ways how to name variables, and this also relates to the modules, and it goes way beyond. So that was enough Python. We kind of took a long on that, so we can move on. So now let's have a drink and let's explain this pyramid. So you know that for the PC you have to have hardware, so that's the bottom layer, where the zeros and ones can be processed. So that's the machine language. Above it is the assembly language. So you might code in assembly. You can always code in assembly, but it's not a really recommended way, because it's making some larger program in it might be very difficult. And from assembly there is high-level language. Yeah, which might be I think it's the idea is that the high-level language is the Fortran, C, and Pascal, and others. So in those languages you don't have to write move this byte to this byte, and very complex way how you have to do it in assembly. You just have higher level, but you still have to keep a lot of things in mind. In example of C, you have to be very careful of what you do with memory, so you don't have overflow and all the other things that you have to worry in C. And above these all languages, you have object-oriented and visual languages. So as Python, that can be Ruby, and all these modern languages. So they kind of hide all these complexity just in some few functions, and not just in few functions, in the whole code, in the whole language. So this is important to keep in mind. But even more important is that you can always dig deeper from the visual language to the C. So we can inject in C code, and in cases if you don't like what how the program works in details, you can always dig in more I mean, there are some restrictions of course, but you can. We will not do this in this course because that's too advanced. But you can always inject in the C code and do some other stuff, so it works the way you want. Let me just write a question. We will have time for questions after this presentation. So, and that will actually be 5-minute break. So I will answer those questions later. There are not so many of them yet. Okay, let's move on. So this is again the pyramid. Another point I want to make actually in this pyramid is that you don't have to reinvent the wheel. So last time, like last year in March, was the Python package index, the PyPy, which is this URL. It used to be different, but now it's now they changed it a few months ago. It's sort of nicer. Anyways, there were. Oh, I see. I have the So previously they were counting in packages. So you see there was almost 100,000, and there just in 7 months 20,000 more, and now it's actually called projects. So we can have a look on the page. So what is on PyPy? That's like the third-party library repository. So we can see there are trending projects, which are like popular right now. So UltraJSON, tracing, whatever that is, image augmentation, and some new stuff. So I mean, you can find probably just about anything in here. So something for Reddit, for example, and you have like 153 projects for Reddit. So I mean, if you have like idea, for example, you want to like do GIS for maps and stuff, just go here. I mean, you go to Google or DuckDuckGo or any searcher, search for GIS and Python, and then you can also go here and find some libraries to use. So you don't have to start from scratch and do everything yourself, because there's already people doing it, and you can just jump on the wheel with them and learn with them, ask questions, use their documentation. So that gives you a lot of tools to play with in many fields. So you can go to popularity. So this is the picture generated by this page. I think it's old. So Java was popular. It was popular like last autumn. I made this picture, but now we can see that Python actually skipped over the Java. So it's very close, but you can see the trend. Java is slowly falling, but Python is rising like nothing else. So 5%, that's a very large, because I mean, just look at, it was smaller. Yeah, I'm not sure what the trend was back then, but yeah, it's really good. So Python is like the most popular language. You can, I mean, there are lots of jobs opening for Python, and also Java. That's also still popular. JavaScript and PHP still very popular. And I mean, it doesn't mean that all these languages are like useless or something. But you see that if you know Python in the IT world, you're probably not going to lose somewhere, as if you would know only Delphi, it would be probably harder. So Python, and you can learn all these other languages and be up to speed with everybody. So we have some comparison. So in C, you would do hello world like this. So you have to include some header. Then you define the main, and then you do the puts hello world. That's sort of simple, but that's just hello world. But you can see the difference, how it looks like in Java. So you have to have public class, public static void, and then print out this. and in Python 3 you just have this. So we can also have look on more Java differences and also have a look on the JavaScript differences. So again, we went over this string operation. So again, this is like too much on eyes, you know, because always Java has to have all these public classes and whatnot. But you can see that it's sort of same. I mean, this is you define string, then you say that yeah you have to do for or whatever. But anyway, in Python you just do this 2 lines. Control flow is sort of similar again, but you see it's shorter. Classes again shorter. This is nice case. So as I said, Python handles a lot of complexity for you. So you have just open function which handles all these input streams and buffer reader and whatnot, which you have to do in Java in cases when you have no library for it. And in Python it's just very easy. Again, in this, so this is not very useful, but just to get an idea about the differences. And this is more interesting, Python and JavaScript. So this is Python and this is JavaScript. So you also have import, which is like importing the library. So something like import this, you can do import math, and same you can do in JavaScript, and it's sort of similar. But and we get to differences, like you see there is the type indentation. So in JavaScript you don't have to have these spaces, you can just use these curly brackets and put everything in one line. In Python you cannot do that. I mean, there might be some way, but it's not recommended. So this is like the main difference you will see, but still you can see that it's almost the same, because yield it does the same thing. I'm not sure where's the star here, but whatever. And yeah, you can see more cases. So when this is for Fibonacci number, I guess, some kind of yeah, you can try it out later in the Python. And but you can see like you have 4 lines in this function, and this function is a little bit more, well, it's harder to read for me at least. So we get the idea. Classes, you know, again sort of same, but yeah, mapping also, yeah. So I mean, the idea is that with the Python, and you just get the work done, and if you have to do it in JavaScript, it's not so super complex to like rewrite it. And you know, what you might get in cases, at least I done it, that I had to do something in JavaScript, but I had no idea how to form it. So I tried the same thing in Python, and then I just I got it working easily, because I knew how to debug and stuff. And then you can use the code to write it in JavaScript. So that's kind of like helpful tool in some cases. So what is the Python used for? So you will see that, you will hear that Python is big in data world. So for cases when we have lots of data, like gigabytes, you will probably hear like Panda library, which will handle all these data and CSVs and make it easier to work with. And based on that, you can do some machine learning, and that's again big topic that will not cover in this course, because machine learning, that's like a whole concept that will take lots of time to explain. But definitely you can find some tutorials, Python machine learning. There are very good ones from Google, from Udemy, and I mean, it's all over the internet. So we can just, you know, have some idea of where machine learning can be used, collect the data. After this course, you should be sort of okay with Python, and you know, just get started with it and continue. So again, more things are like rapid prototyping. So if you have some idea and you are not sure if it will work, you can just try it out in Python and like spend 30 minutes testing it and either it works or not, and you either wasted 30 minutes or not. Compared to other languages to implement same kind of logic that would take more. So this is kind of the advantage in Python, that you can do it, and if it works but there are some issues, you can rewrite it kind of easily because you can reuse the code. So the stuff you don't like, you can throw away. So that's kind of the point of throwaway ad hoc programming. And other stuff are like scientific applications, so weather calculations, medical stuff. I think there is a link for this, yeah. So then extension languages. So for example, there's this game Assetto Corsa, like racing game, and it has widgets you can use in game to display you all kinds of information from the engine, like how many RPM and the tire pressure and everything, and that's all linked to Python. So you can write your own widgets to do whatever you want, and that's for other games as well. For example, the Sims 4, I think it uses all of the code in Python, and actually you can kind of decode it and do stuff with it, and also in programs. So there are many like WeChat and kind of like other like software, some file managers I think written in Python, and you can just have Python plugins. And so Sublime is this editor Sublime. Where is it? No? Yeah, this is Sublime. You can use all kinds of there's Anaconda for, but we can get that later. So that's extension language. Backend web, so there's Flask, Django, Pyramid, lots of web frameworks that run the whole web server. And XML processing, so not just XML, also JSON or just general data processing. So you have some kind of huge XML and you want to take some data from it, so you can use Python to just go over the XML, take what you need, and dump the rest. Because that's kind of tricky, because if you load the file, it might take a lot of memory if the XML is too big, and they usually are. And the next example is database applications. So I think we will have time for SQL Alchemy, which is a very nice way to work with databases. So let's say you have a idea for a program and you write in SQLite, and if you use SQL Alchemy, you kind of map the whole way how you work with database. And if you want to switch to another database later, you don't have to rewrite the whole way how you interface with the database, because normally you can use just SQLite library. So let's say with SQL Alchemy you want to switch from SQLite to Postgres, so you just change the engine and a few other things that are related to Postgres, but the general workflow with SQL Alchemy should be the same as is with SQLite or other databases. So it's like very useful, and especially in cases when you have to take some old web application when there are old data and it's hard to work with. You can just clone the whole database, work with it, get the idea, get the SQL queries for what you want, and just work with it much faster. Another example is GUI applications. So there is, for example, like Calibra. I don't have it. Calibra is for managing ebooks. So that's all in Python. Then there is the Sunflowers. This is everything written in Python. Many other programs like that. And last thing is a glue language. So let's say you have a thing in Java or I mean, whatever JavaScript or some old language, and it produces some output, and you need to take that output and put it to another system. So instead of editing those systems, to generate this output like this, so this other tool can read it well, you can just do the middle. Just take this output, do this, and generate the input for other program. So we can start the practice. That took just over 40 minutes. Oh, close to 40 minutes. So you can use this git clone, this repo. I pass this IRC, and if you use Arch Linux, you probably just do, as I've written, it's written in the, let's just go there. Yeah. So Postman as Python 3 IPython sudo. So I have it installed, but these two packages is what we will need, and I'm running Jupyter Notebook, which is you see the Jupyter. So that's Jupyter with like that, and that the Jupyter has the shell notebook, and it has IPython in it, because this is kind of the IPython in web browser. You will not need this today, but if you are on Arch, it's pretty easy, and this is like how you run it. Yeah, so you will just download these 3 packages and run Jupyter Notebook, as I'm already running here. So it looks like this. It tells you there is some web server and etc. So we can get ready. I will now answer some questions, and let's have a 3-minute break, and then we can continue in this day 1, almost all basics from Learn Python. So time for questions. Yeah, it's probably the stream is there's some delay, so as I'm writing on IRC, I'm still talking in the stream, I guess. So what were you talking about? So sparse dense coding. Actually, I'm not sure. Let's have a look at the Zen of Python, because I actually probably didn't explain everything. Yeah, so there is my explanation here, and you might find some videos about the explanation of the Zen of Python, but I guess everybody has their own explanation. Let's just Google it. There might be some examples. Yeah, so we see, yeah, it's not Stack Overflow, it's something else. Oh. Okay, so this example about rats. I guess. Yeah, you can have margline breaks for the readability. That again fits in with the PEP. So I guess I have some code. Okay, let's just let's write some code, like says syntax to Python. So import this, and I will show you some function, and just pass. So this kind of thing I want to show, that the PEP8 is showing some warnings. So no new line at the end, that's easy to fix. Then there is the expected 2 blank lines. So before the function you should have 2 blank lines. Indentation contains tabs, so you can do convert to spaces. That's again fixed. Yeah, this is not used, so this is just, we will not use this, so we can, yeah, this will make more sense. this is exit. So idea is that let's again make a new line. So if I make 3 spaces, it will not yeah, again two black lines. Yeah. So this is Anaconda in the Sublime, so it kind of helps you with the formatting. So if I mess it up and do, for example, this, I can do auto format Pep8 errors, and it will fix it for me again to the 2 blank lines before the function and after the function. So you can make more blank lines, but you know, the Pep8 will, like, if someone opens your code and says what is this mess, they can do auto format in Pep8 and they will just have the Pep8 standard code. Okay, I will also have a break, so okay, let's make it actually 2 more minutes, 9:50, and we can start with this. So everything in here will be shared, so no need to, you know, write it on your own. But actually, let's make the interaction to Python and IPython and stuff. Okay, I'm back. Can we start? Okay, so that was a break, and now we can continue the coding itself, the IPython notebook. So yes, so that's like we should do some introduction for the IPython itself. Actually, as I said, let's do the you know, IPython and Python difference. So let's say just run Python. If everything works on your system, you should get these 3, how it's called, these arrows. So let's say I run the same code as this, which is defining string I don't like today's weather to variable called text. So if I do that, I don't like today's weather, yeah, and now we have it defined in the text. So if I write just the text, okay, that's good point. Actually, let me try to fix it. Yes, the OBS, because this resolution is, you know, 120 pixels. How do I fix it? Yeah, actually, yeah, I would have to. Yeah, this is okay. Let's just do it the bad way. No. Okay. Some tricks. Let's just remove the, set the mode to full HD because this kind of monitor is still 16:10, and everything works now. Yeah, it's broken. Yeah, that doesn't work. Okay. Yeah, that's the correct one. Okay, what I will do is I can switch to other screen, move it here, like this, and no, not this one, this one, and I can move, yeah. Yeah, I cannot adjust the OBS resolution on live. I will have to stop the recording, and yeah, so this should be fixed now. Where do I have it? Again, and now, yeah. So sorry for that. I guess in the recording we didn't have issues with the 120 pixels being cut from the button, but right now it kinda is important. So this is all okay. So again, let's define the text. So notice that even when I exited the Python shell, there is still the history. So I think it's saved in our home folder in some Python hist file. So again, let's get back to it. I will define the text, and now I will just write the text and it's there. But if I want to see what kind of options, it actually works now. This is interesting. But it might be some of the plugins. So this is not probably supported in normal cases. It kind of works here for some reason. But the idea is that the text is an object, and you have all these functions in this. And the Python, maybe it kind of works now, I'm not sure. But the idea is that we will use IPython. So if we define I have some complex thing in there, but I will just write the same thing. And it works the same. You see there is some nicer coloring, and it works the same. But this is kind of like better. You see this, I use text and dot and hit tabulator, and I can go all three these options. So if I will just hit enter, it will tell me it's a function, so I can ask what the function does. So it tells me that returns true if title case string in and there is at least one character in S. It's probably I can just try it. Yeah, so this is not the case, but if it would be like yeah, so it's for the at least one character in the string is upper, and and the rest is small characters, I mean lowercase. Yeah, never mind. This might be useful for some case. The idea is that you have all these functions, and you can just it will work on any object which will have some functions, which is everything in Python. So that's the kind of difference why we use the IPython. And the Jupyter Notebook, let's move it here. Yeah, zoom in a bit. It does the same thing. So this intro to IPython, I mean the Jupyter, you see there is always in and out, which is like same in here. Yeah, because the normal Python doesn't show you. So this is same IPython in Jupyter. It runs the same kernel. So you have like input cell 3 and that returned output, and you can see that in the first cell there was no output from the declaration that text is the string. So that's important to note, as I wrote here. Yeah, so cell 1 didn't return any output, cell 2 did. So we can run it again. I run it with Shift Enter, and you see it runs the same. Yeah, this is the comment. So what I want to explain here, that I can actually insert it. Strings can be defined with single quotes or double quotes. It doesn't really matter, but in this case, if I would do single quotes just here, it wouldn't work because I end the string in here. So it tells me syntax error, that it cannot complete this line. So I could escape the characters with slash. Where is the slash? Here. And that would work, and it would be same like this, but it's actually, yeah, printing again with the double quotes. But I guess we can all agree that what was there previously was easier. So if you have like complex string, I mean, in English, when you use these apostrophes, which are like the single quote character, you can just get used to writing double quotes and whatever is inside. But you can also use for some simple strings these single quotes. Yeah, so yeah, cell 6 not returned some output. Actually cell 6 7 now because I ran the thing here. Yeah, well, that can be, if I will do it again, actually I can restart the kernel, so it looks nice. Yeah, I can also clear the output, but I don't want to do that. Yeah, 1 2 3 4 5, now it's 6. Yeah, just to make it consistent. So we can go to built-in functions. So that's this link. That's linking to the documentation of Python 3. Actually, why 3.3? We can. Doesn't mind. Never mind, actually. But this should be the correct link. Yeah. Okay, we'll just fix that. So this is actually Markdown. You see there is the Markdown, and this link, yeah, this is just Markdown link. So you can just edit the link like this and Shift Enter to fill in the Markdown. Yes, so built-in functions. So you have all these functions. So if I go to the IPython, I don't want to exit, and for example, let's check the ID. So ID returns identity of an object, and what that means is that it will tell me some number which is in the memory. So that will be useful for one thing I will explain later, when you have linked objects and like copy of the objects. But the idea here is that you don't have to import anything, and you have all these functions. So you will probably use range in some cases, the input for getting the input from user. Type is also very good. You can inspect what text is. That it's a string. So interesting to know that the string has all these functions, and the string itself has also these functions. So that the text kinda takes from the string class, let's say, and inherits all these functions. So that's his built-in function. Just from it, what you need to remember is that you just run Python and you have all these all the time, so you don't have to import any libraries for this. We will use some of those when we will have time. Print is like what we will use definitely, and this is like interesting for the documentation. So we have like a print. It takes some objects, and you can see there is a star. So it's like takes a list of objects. Yeah, because you can. I mean, you will not pass the whole list, but you will just print. Just actually show it. Print string A, comma, string B, and it will print it like this. Yeah, so that's kind of the star. That will make more sense when we get to the keyword arguments and arguments and keyword arguments in functions, which will be other lecture. But what I want to show here is that the print, it's kind of prints the same thing. That you have the value, then the separator, some end, file, and flushing. So that these are all the options for this function, and it's also described here. This is like shorter, this is like longer. So always just docs Python built-in functions or whatever the library will be. I mean, for example, some collections library, and you can just easily find it on documentation. It might be like harder to read, so you can go on Stack Overflow for some example or some other place, but always keep in mind that the information you find on the internet might not always be the perfect golden solution. You always should think about why you're doing it, what is going on, and just think about it critically. There's actually it will not work for this. So two question marks is like bigger help, and that will make more sense in some other case. So we can continue. So yeah, in cases where you don't have like no way how to display what the object has functions for, you can use the function dir. So let's check it what it does. So you just use dir and the object, and it will return a list in the current local scope, return the list of names in the current scopes. Yeah. So you notice that the text has all these capitalize, find, and etc. So if I do dir text, I have all these as well, and I have something extra. All these underscore, which is in English I hear called underscore. So this is like internal functions for working with the object. So some of these functions, I don't have an example, but they might use some of these. This is for example nice. So text is it's a string, so it's like series of characters, and we can iterate over it. So actually, let me try something. I'm not sure if it will work. Next iter, yeah. So yeah, this is not a good example, but the idea is that the iter returns like the string itself is iterable. So you will get to this as well. This is like the loop. So for a character in string, in text, in our case string, in our case the text, print each character. So it prints each character it found in the string and prints each on new line. So that is possible because this object has done the iter, and that will make more sense when you get more into what's iterable and etc. It's kind of mouthful at first, but it's kind of simple in the end. So that's just to know the dir function. Next, Yeah. So what's next? Yeah, so again there's the like len function. You can run it in here directly, so 28 characters. Is it true? We can actually check. Len text, it's actually 28, and we can try it like this. So we can define like count. It will be like start from 1, and then in this block we can do like add 1 to count and print it. So yeah, we started from 1, so in the end it's 29, but you get the idea. It's really 28 characters in this text. So yeah, and then we can access each character. So as I said, the text is a series of characters. So we can access the 28th character, which is the vendor. So that's R. That's the same as the last one. So I mean, let's do it like 26. That's vendor. That's E. 27 is what I counted. But if I don't want to count and just want the last character, it's -1. The text, yeah, we can also do like this is actually called how it's called, string comprehension. No, it's list comprehension in Python. So it's like no, sorry, string Python slicing. Yes, that's slicing. We can link to this, for example. Yeah, this is like nice example. Yeah. So the idea is that yeah, you can access each character by the, yeah, this is the part I wanted to show. So this is the Don Quixote, and from character 4 to 8 is, so it's these. So from 4 to 8, yeah, so that's kind of the same thing what we are doing. And actually I'm skipping too much, but yeah, let's get to these. Let's get here. So this is string slicing. You can link to this, for example. No, not this link. This link. Sorry. So you get the idea later. Yeah, so from starting to 5th character, it's actually, yeah, so this is just from 0 to 3, and this is like the 5th. I'm not sure why it's like, how it's counted exactly, but you get the idea. When you have some string, you can just try it out and get what you want. The same way is that you can, because as I wrote here, there is like from 0 to 5, and the same thing is, I mean, this is the same thing. So if you don't specify the 0, it will, just the semi, how it's called? Column, yeah, column. From 0 to 5, so the same, you don't have to write the 0. Yeah, we will get to regex later. So then there is also like to the other way, so from character 5th to the end. So end you don't specify, you just do the column, and then there are some tricks like reverse the string. So that's like 2 columns and -1. Again, not I don't have the explanation how it works in the details, but if you just Google for Python reverse string, you will probably find something like this. So we tried this ID in number in memory, and yeah, let's actually run it. So this is like different number, because it was old information. I can ask what the ID Apple has, and I can save it save the apple to the test, and yeah, that's different memory. But now when I do the ID apple, it will tell me the ID of the test. So actually, how to explain this? Well, the idea is that the Python is smart, and if there is some string in the session that you run, and you ask for it, so I define the test, and the test has content of the apple. So if I ask for the ID of the test, it will tell me, oh, it's the string apple, and I ask what's the string apple, and that's the same object, so it's linking to the same object. So if I actually did I can do it in one line, I think. I have to just recenter. So let's redefine the test to something else. So like banana. Yeah, it will be different string. I mean, it didn't print it because it's one cell. So you get the idea, I guess. It will make more sense again when we will show the difference like between two equals and is, because that's like comparison of the objects. Yeah, see, so we redefine the test, but I mean redefine the variable, but is this still the same? Sorry, this is the test, and I kind of got confused in there, but yeah, we can continue on other functions in the other built-in functions. So we actually skipped through the very important part, that we are saving the values into some variables. And I kind of showed it with the ID now, that as you have defined something, you save it to a variable. So let's kind of clear this. Yeah, it works. This was a magic function of Python. So you have like magic functions, all these under the percentage or 2%. So for example, the who, no idea what that is. You can ask. Print all interactive variables. Yeah, I have. Yeah, this is all the variables I defined before. So her, count, and text. Anyways, this is just an example. So let's do clear again. So what I wanted to show, that I can actually, let's show it here. So you can just write text as it is, so whatever, and that's just there. It gets lost. So you save it to a variable, like you do something equals this. So the Python always will run whatever is on the right side and then save it to the left side. That will make sense when you are saving some function, like do this. If we have function, so it will run the function first and then save the result to something. So let's just save some string and we have it in something. Again, we can do the ID trick, that the ID of something is this number and the ID of string AAA is the same number. So you get the idea that Python interpreted the thing in the session. It saved the it's so that we want to save 3 AAs to variable something. So it specified a room for it in memory. So when I ask for it later, it will just get to that memory. And yes, so that is a string. Now what I want to show is numbers in general, because we got this int and string and etc. So numbers in Python. So one of the ways what I like to use Python for is just a calculator. So let's say I have 5 and 90, and then I want to split it to 4 people. So I can do this, and I can do also something like this, and now I get to the different parts, so you know you have to can do this. It will work. Actually, I wanted to do this. Yeah. So yeah, you get the idea. It's just math. But you know, I'm just throwing numbers here, and they're not getting saved anywhere. And actually, we can see a different interesting difference, that the type of string, I mean the number 95 is integer, but this is not integer. So what is this? We can ask the type for all this whole thing. That's float, because float is something else, and that is the decimal point and some details. So I can also save this to a variable, so some calc equals this, and type calc is, you know, that's the float. So when we will work with user input, so we can try it. Say me a number. So let's say you will have some game and you will ask the user for a number. So you will this input function tells that, you know, asks the user with the string, and then whatever I write and hit enter, it will return. So we can save the result of this question, and let's make it nicer. So I do comma and space, so we have it like this, and I do, you know, 99, and we have it saved in the result. Again, note that when I had the input just like that, it returned me 8, but when I saved the result, there was no output. So that will be important later. But the idea is that the result is 99. But you see these single quotes. So if I ask what the result is, of what type, it's a string. Because input always returns a string. Yeah, it strips a new line. You see there is the prompt, which is the same me a number. It should be. Anyways, yeah. Yeah, if you hit Ctrl D, Ctrl Z, it will raise this error. That's okay. Yeah, I mean, the idea is that it always returns a string. So if you want to convert the actual result of the string to a number, you do int. So int result will return me actually the 99, which we can check the type of, and that is int. Yeah, and yeah, we can get back to this point. So that was, we kind of went through very fast through strings and integers and floats. So I mean, this is the same thing I just explained. The integer 555 converts this string 555 to a real number 555, and it works the opposite way as well. So you can convert any number to a string in some cases where you might need it. But what will happen in this case, when you try to convert text to a number, it will tell you invalid letter for integer with base 10. So it doesn't know, I mean, the text cannot be converted to a number just like that, which might be important when in this case the user, you know, I will say send me a number, and I will say and the result will be and if I will try to convert it, if I have a code to convert directly the whatever the user wrote to integer, it will not work, you know. So this is like we will get to the how to fix this, how to handle this, but you know, just keep that in mind that this might happen. So just to get an idea. So I don't know why I had this practice. Yeah, so number, yeah, we went over this. So now we get to the important part, the types that I kind of went through, and we can go to list of operands, yes, and then yeah, that's the truth about testing. So now this data types. So actually let's make a short break, like 2 minutes, to ask questions. Questions time. Yeah. There is for regex, there is the slime array called re. Yeah, 3 seconds of delay is nice. So for regex, there was a question about about we did the string slicing. There can be also regex used. That's very powerful, and we can get to it one point when we have some kind of example with some string format. I mean string, processing. Regex is very powerful. I like it. And what the other guy is saying? Yeah, garbage collection. I'm not sure about that. There is garbage collection somehow. Yeah, there's interface for it even. Yeah, but there is some nice blog post. How it works. Yeah, I will not get to the details of this, but if you are interested in how the garbage collection works, because that might happen in cases when you have just too many variables in the whole Python session, so it has to clean up some way. I don't have any example right now, but if you just read about this, you might get the idea what it's all about. As I said, this is just for Python beginners. I'm not some special programmer. I'm just I don't have any special education. I just know what I want to do and how it works. I mean, how it kind of works in a simple way. Because you don't really specifically need to know all this stuff if you don't have some kind of special issue in that area. But you can always find some explanation, or find someone who will explain you or get into the issue with you and find the solution. Question about typecasting. I have no idea what typecasting is. What's typecasting Python? Again, I don't know what is typecasting, but you can find it easily. Typecasting. What is typecasting? Implicit type conversion, explicit type conversion. Yeah, so that's the point when you do things like readable or in a hidden way. So typecasting is general programming term. Too many hard questions. Let's continue. We just have like 35 minutes or so. So let's get to data types. Yep. Yeah. So all these questions on IRC, that will be logged with the video, so you get the idea what we are talking about on IRC. It just sounds very specific things we don't want to talk about right now. So data types. Where were we? Here. So this is just some article I googled about the data types. So yeah, we have all these like boolean numeric types. So int, long is only in Python 2, float, yeah, okay, and complex, yeah, also. Then there is like sequences. So as I said, like string is a sequence of characters. Then we have bytes, you know, list and tuples, and we have also sets and frozen set, yeah, and dictionaries. Dictionaries are very big ones. Interesting to know that there are some data types are immutable and some are mutable. So content of objects of immutable types cannot be changed after they are created. Yeah. Only mutable objects support methods can change object in place. Yeah, that's the interesting part. I mean, important part. We can have some example in Python. Yeah. I mean, this kind of interesting with the string, but the idea is that yeah. Yeah, here is the example. So A1 that's integer, S is a string, and this is like list comprehension. Now this is like, yeah, this is a list. Then there is an integer, then there is this is a tuple. No, this is not a tuple. What's this? Actually, if I'm not sure, I can just copy paste, and you know, this is the same thing, and I can just show you how to access the, you know, when we had the text and I did -1, I accessed the last character. So the same way it works with lists. So length of a list is 3 index and 3 3 items in it. So if I do L0, that's the first item, a string, this is a integer, and this is, I wanted to ask what this is, and this is a tuple. I was not wrong. Yeah. So tuple is like set of things that you don't want to change. So actually, no, not this. I can save it to O, for example, and I can see just the 3 functions for the tuple. So we can just count the things, ask for index, and what is this? This is new. It wasn't here a few versions back. Anyways, the idea between immutable and mutable as is written here, you know. Objects of immutable types cannot be changed after they are created. So the tuple, where's tuple? Yeah, tuple is immutable. I like the example of tuple because, you know, of course you could for example, because you can access the tuple same way as you did the list. So I'm wrong. No, how do we do it? Empty, not. What the hell? Because yeah, I did it wrong. What did I do? O is not the type. Always O should be the just this. Yes. So now we can access it. And this shouldn't work. Yeah. So this is a nice example. This is the list we had, and I can, for example, change the index of the 1, the 546 to, you know, whatever, and that works. Now the L is a string and whatever, and the tuple. But with the O, I cannot change any index in it. You know, that's the difference between immutable and mutable, because list is mutable. Yeah, so that's kind of the main difference. And yeah, we will get to these slowly later. each data type has its own function, function or use case. But interesting to note that, for example, I can do quickly import requests, and I can do like requests get arcnux.org. So it's kinda, I have to do HTTP, and that will return me a response. That's OK response. So I will save it to A, and I can ask, so okay, actually, to make a good example of this, connection. Yes. So this is a sort of like data type. I mean, actually, it's a sort of a class, but say if I do that's kind of the whole list. This is a tuple, but yeah, I mean, it's not really a data type, but any library, because requests is, can, for example, ask for docs. No. Well, anyways, the idea is that any library or anything you write, you can like specify what will be its functions. I mean, its structure, and you can have like this request as adapters and as HTTP adapter, because that kind of makes sense in the crazy HTTP world. And because if I ask for the type of the A connection, it will not tell me it's some whatever. Stuck. Yeah, A connection. The type of it is this request adapters, HTTP adapter. Yeah. So it's not just these data types we saw here. It can be anything. You can just specify anything, and lots of libraries do that. So don't be confused when you see something else than these basics ones. Yeah, we didn't went over the operations, so this is interesting to try. So like math, you can do addition, subtraction, multiplication, division, modulus, and exponent. Yeah. So A to B, let's just do this. A is 2, and I can do A times n, gets like 32 times of 32 times the ATC math. So this is was not clear from this case. Yeah, the floor division, so we get the you get 4, and then there is the rest, which is 1. I mean, no, that's modulus. Sorry. Yeah, floor division is something else. Yeah, quotient, which is after the decimal point, are removed. Yeah, I don't get this. This is math. I'm very bad at math, but you can use it in some cases where you can use floor division. This is more interesting. So the operator is plus minus ATC. So these are arithmetic operators, and these are comparison operators, and then there are also assignment operators. So let's go to assignment operators first. I already shown we can do it backward. Yeah. So in this case we did count plus equals. So now I can show you that count is 29, and if I want to add one, I can do, for example, count equals the current count plus 1. So now the count is 30. But to not write it like that, I can, let's do the subtraction right now, and I could do the same count equals count minus 1, but I cannot do also this minus 5, and it's like shorter way of writing the minus 5. So as we went to the subtract, you can do the same. Just, you know, do the operator and directly equals, and it will just, you know, save you some space. And then bitwise operators, binary shifts, that we will not do that. I don't have any example for that. That's too complex. Now you get to the comparison operators. So let's check this actually. Let's close this. So yeah, it's bool, and we can get to the ifs and else. And that's actually dict. Yeah. So let's do the comparison thing. So in most easy way is like, you know, asking if 5 is equal to 5. That's true. 5 is not equal to 4. That's false. Same way, you know, 5 is larger than 2, and the opposite way, 5 is not smaller than 2. So you probably get the idea where this will get used. Let's say, yeah, I still have the text, and I can, for example, ask if, you know, this is just an example, text length of text is shorter than nice. Oh, then length of nice. That wouldn't make sense, right? And what? That's smaller than, yeah, the length of text is larger than the length of nice. So you might get to some, let's say you writing a program which will ask if the one string is larger than the other. So we can actually write it real quick. So yeah, actually we can yeah, let's do it quickly. So we can do print text, and we can actually do also this, like I don't want to make 2 lines. You don't normally use that. This is just an example, but you can do it like this in one liner, like write something longer than the text above and save it to queue. So it will print me the text, and I will try to write something longer than the text above. So all this whatever. Now it's saved in the queue, and let's say the program continues. So you do the length of text is larger than length of queue. What? Length of queue 88. Length of text is 28. 28 is, yeah, again I got mixed up. So length of text is smaller than the length of, yeah, that works. So this is a strange example, but in the end, in the program, you would write if this is true, like print, yay. And yeah, I will show you like, yay, this is the string. Then you print the content of the variable q, comma, is longer than text. Yeah, you get the idea. So actually, to make it more clear, if true, yeah, that's always, you know, true is true. So if that condition is satisfied, it will print the block inside. I didn't explain the very interesting, very important part in this, that as you write the if true and do a semicolon, you hit enter, and IPython directly does these 4 spaces for you. So that's 1, 2, 3, 4 spaces, and you know that's the indentation. I just printed the string. I mean, I didn't print the string AAA just to show that the indentation, the code works, but just nothing happened. Okay, do the print. If I do like 3, it will still work, even with 2 spaces. Is it 2 spaces? Yeah, and even if with 1, it will work. Yeah, but you know, you get the idea. It's not really nice. But this will not work. Yeah? It will get indentation error because it expected an indented block. You can also do this, but you know, remember the readability. Just stick to the 4 spaces. Yeah. What I did is the Vim example. I mean Vim shortcut dd remove the whole line, and in IPython you can enable this Vim like key shortcuts in some settings. I think I have it in yeah, where is it? Yeah. So this is kind of like IPython. So this is cterminal interrupt shell editing mode vi, and you save it to your home folder, IPython profile default IPython config. You can Google it. Yeah, I mean IPython remote. Yeah, this is the, where is it? It was probably, yeah. No, it was somewhere in here. Yeah, skipping away. Never mind. Where was it? I'll just Google this and save it to the. I will save it to the Git repo. I'm in different window. Never mind. Too much coffee. Yeah. Yeah, see the interrupt shell. Yeah, this will not work. Yeah. Yeah, we are skipping away. Never mind. This is not important. So, anyways, this is the if block. So let's do actually if false. So, you know, print never happened. You know, if the condition is not satisfied, it will not go there. But you can do else, you know, and if false and anything else, then yes, you know, it will skip false but continue to false. That will make sense if you do the you use page up, page down for skipping those blocks. So if we have like line text, this is true. If I do the opposite, it will be false. So if I like complete this and say, you know, print yeah, what I'm doing here, length of text is smaller than nice, which in this case is not true, so I do else and do print length of text is, actually I mixed it up again, is larger, and length of text is, now come on, it's larger. And nice, yeah. So you get the idea. If len, you know, this is not satisfied, so it goes to else and prints the other thing. There is also elif, so I can do like in the same case, like elif true and else. And this is the important part, that in this case, this is like, this whole thing like is like one if else block. So only one condition from this block gets launched. So in this case, I did like, this was false. So I ask again, but else if something is true, print this, and it will not even get to this point. So it's important to note that we have like these blocks, because so you might remember from Bash that you do if, and then you finalize the whole else block with fi, and in this case in Python you just do new line and that's it. Because if I do if true, print 1, and if I do if true again, that's two else blocks, and that will work like that. So important to know. And one more thing about if and else, we can have like one-liner. So I can say doc if true else get. So true is just the condition we satisfied, but we can do like 9 is larger than 8, and if I reverse it, it will be the cat. Yeah. So if you have like simple one-liner, in some case you might use this. So a very interesting thing I forgot about is the boolean. So you see that boolean, that's bool true is true, of course, and what's more important, that bool of 0, that's false, and bool of 1, that's true. So you might imagine like a voltage. If the voltage is 0, nothing is on. If the voltage is 1, something gets moving. So this is kind of like whole example. So for example, I can do like if I have like verbose flag. So verbose, let's set it, and I have some program, and I do if verbose print more details, and boolean of verbose is false, so it doesn't get satisfied, so it doesn't print the more details. But if I set the verbose flag to true, it will print it. Yeah, so let's try it. That works. So this is the same example if you do like if you have a list. So let's make like fruits is empty. So if fruits print fruits, so nothing gets printed because fruits is empty. You can check it like this. That's false. And now I will show you list function to, because fruits is a list. So fruits has function append. So let's check that. So append object to an end. We can do also insert, but that requires an index, and we don't want to specify index because we don't care about the index right now. So we can just append apple, and fruits is now, it has apple in it. So if I do bool fruits is now true. So if I go back to this block, it will print me like this. Yeah. So that's kind of like to explain this whole, where is it? Yeah, the truth value testing. So actually there is like documentation about it, and yeah. So yeah, and yeah, we interesting, or and not, very important. So just get to this part first. So as I said, it's like voltage, like voltage 1, no voltage, no go, move, yeah. And yeah, this is like example of text, and it has function is lower. And yeah, this will be 10 minutes to go, so we kinda yeah, we have this notebook to go through. So text is lower, that will actually, let's check here. Text is this, text is lower. You can ask, return true if all characters are lowercase, which is in this case is not true, but I can do like text lower, and of course this will work. Yeah, make all characters lowercase and then it's lower. So again, I can do like if true, and I can do print all letters in var text. You can do, for example, like this. Yeah. R lowercase, and I have an error here, and it will tell me where the error is. I didn't finish the string, so that's one of the cases. Yeah, so that makes sense, right? We went over this, the debug or verbose flag. Yeah, debug mode, verbose mode. What's this? Bit length? No idea. I have to remove this. Fruits, we went over that. Fruit insert, append, and we can also do pops. So removes from list and returns it. That might be useful for in cases when you are going through the list and processing it. You can also remove the elements in the list. And now we get to the dictionaries, and let's check what else. Tuples, yeah, important and unpacking values. That's very interesting. We can show that in the dictionaries. Conditionals, we kind of went over that. Yeah, I'm sorry if it's like here and there. I just, you know, get the idea and show you directly in here, but by reading this and launching these blocks, you should recall what he explained in this stream. And then we get to the iteration, and then there is this more difficult iteration. So let's actually make a short break. How much time do we have? Let's do 15 minutes. I'm asking RC if we can make it a little bit longer to finish all these stuff for this session. And actually there will be like homework for all of you. Now 15 minutes to go. Few minutes break if you like. So actually I will link to this. I have to beautify this whole notebook. So yeah, as the note says, almost all the basics from Learn Python. So this is definitely not all the basics, but yeah, actually yeah. I don't believe we run through all of this with 1 hour. So yeah, I mean the idea is that in the end you will get through this learnpython.org and try everything out. So you have like this section of conditions, so it will like explain you what is going on. Yeah, that should make sense after this. And then you have like some exercise, so definitely go through all of these so you get some practice. So I will link to this in the notebook. So let me insert, let me markdown, checkout page, learnpython.org, this link which explains all of these topics and gives you exercise. Yeah. Okay. So it's probably already. You didn't have the break really. let's continue. If you have any questions later, you can, ask me on IRC, or just prepare for the next session what things are not clear, and we can have a few moments to explain the unsure things. So we ended somewhere in here. Yeah. So debug mode, the fruits. So the fruits, we went over that. Yeah, this is nice way if you want to write fruits yeah. So this is one way to write lists. So just define this, how is it called? This is square bracket, and I should have named in data types that the square bracket thing is always a list. That's easy way to identify. You can always try type and the name of the variable to tell you that. But the square brackets, that's probably a list. And so you because I shown you that I defined empty fruits with these, so that's you define a list. It's also you can do yeah, that's also one way to define it, but let's just use this. So in this case I define fruits, that's apple and big banana, and you can also do define a string and split it. So it was by default, let's have a check, string split, it will by default split by a white space. Where is it? Yeah, if step is not specified, it's none. Any white space string is separated and empty strings are removed from the result. So I can define the list as this, but if it splits by by white space, it will have 3 elements. So it will work like this. So this kind of trick to split the words between to the list works only if you have something like this. And actually we can go to the sets. So in this case I have 2 apples and 3 apples, and then there is different apple, which is the P uppercase, and pear and watermelon. So that's this, and with the set fruits it will do the unique, so it will only print out the unique items in the fruits, which might be definitely useful in some cases where you just want to find the unique items in the list. So that's kind of set, one of the uses of set. Yes, string split changes to the string, you split it and returns a list of the words. Yeah. So that's vegetables. Yeah, you can do the count. So yeah, so actually this is more important thing, the these curly brackets. It specifies a set and also dictionaries, but you will see the dictionaries in a minute. So what's this? Vegetables. That's this. Yeah, this is a tuple, immutable type. Yeah, and you don't need to write the parentheses, because if you have just these 2 strings in a separated by comma, it's a tuple. Yeah, we will get to the dics in a minute. So vegetable, that's the tuple, and tuple has only these functions, so count and index. So yeah, as I said, this is same thing as previous. C is the same thing. it's actually, I didn't printed it. Let's do it like this. Vegetables, and note that you can also use stamp completion for the name of the variables. So this is just an example, and yeah, this is like count example. So it counts, you know, in the tuple of vegetables there is only one carrot. So this is the thing. But yeah, index is also like yeah, you can do the index as well. So I want to find which index is the beef fruit on, and it's on the first one. If I try, for example, something else, no, index not in the tuple. So that's just one thing to say, yeah, because that would raise an error, and you would have to catch it. We will get to it later. So now we get to the dicts finally. So dict, come on. So yeah, new empty dictionary, dict, just like that, or you can just specify the as like this, and it's also dict. So that's same with the list, you know, or you know, that's the same thing you can do. Yeah, that's the same. So what is the dictionary? So you might think like you have a like word from English to Spanish, for example. So you know, and the word in English, and it equals the translation in Spanish. So in this case we will do just context. So it can be used for many things. You know, the dicts are all over the place in Python. I mean, lots of things are just because dicts are faster. There is like nice presentation from Raymond Hettinger about dictionaries in Python 3 specifically, how they work in details and etc. I will link to it in this IPython notebook once I edit it. So just get to the point of context. So I can just copy this. I'm like, is it lazy enough, right? Actually, let's just do it here. So I specify context, and I start with these square brackets, and then I have key Jane and the value some number, and key Joe and some number. So if I print it, it will print me like, oh, this is a key Jane and it has value this. So now to see, you know, the context, actually let's check what it has. So I probably didn't explain this, that you have all these IPython functionality also in this IPython notebook. So you get the keys. So actually we can ask what it does. It will print me here. You know, set like object providing a view on the dictionary keys. So let's remove this. So as I said, Jane and Joe are the keys, and that will return me this, and we will show how to work with that later. So I can access the dictionary of the context to print me just the value of the Joe. That works. And if I try to print something that is not there, it will tell me a key error, and it's not defined in the context, but I can define it like this, and now it's there. So that's very quick for dictionaries, but we want to do more. So context values, that will print me all the values in there. And now there is the interesting part. There is actually, let's make a, I have to do again insert. There is also context. What else is there? So there is, you can update. See, that's nice. So let's say I want to update who's, for example, Joe's contact. Actually, how do I use it? I forgot. Yeah, I have to, yeah, so E is present, and the value. So I want to update. I have to specify a new dictionary, I guess. The key Joe, and no phone, and now it will be updated. So update dict with a dict, because this itself is a dictionary as well. It has key Joe and value no phone. And more things about dictionaries. Contacts. Oops. Yeah, items. And there's also pop, so you can like remove the item from the dictionary and process it somehow, but you remove it. So keep that in mind. It's like destruction, the destructible way. This is interesting. Contacts items, and this is interesting because this is a tuple. This is a tuple as well, and everything is in a list. So now we get to the iteration. So we already went through this, that we have fruits, and it prints us fruits and everything. And we can do the same with the dictionaries. So there's a couple of ways. So if I want to do for contact in contacts, and just print the contact, contacts. So if I make an error in the name of the variables, it will raise me a name error. So if I do it correctly, it will work. Yeah. So this printed just the keys. So if I do contacts keys, that's actually the same. And I could do something nasty like print contacts and then access each contacts of the contact. I cannot write. Yeah, but this is very ugly, because this is actually the same if I just do, well, actually this is like yeah, I could print the contact and then the value of the contact in contacts. So I really cannot write. Yeah, so this would work, but this is very ugly. So I can do it much nicer. If I do for key value, actually I am skipping, for item in contact items, and just print the item. Hey.
Oh, Helen.
I'm just finishing with some presentation and I will get back to you. So if I have for item in contacts, I can print it like this, and you see that each item is like a tuple. So yeah, that's all tuples. And nice things about tuples that you can unpack them. So if I do for key value in contact items, I can just do print key and value, and it will be same as this, but we can all agree that this definitely looks nicer than this. Yes, so we are about all of the time is running out, and we will skip this. I will move this to another lecture, functions, and yeah, the enumerate is also very interesting. We can get back to it later. And that's actually it. So I will just edit this IPython notebook a bit to get summarize everything we done. Yeah, homework is definitely on this learnpython.org. So let's make a doodle or something to agree on the next session. Maybe in a week or in 2 weeks. Maybe in a week will be okay. And yeah, that's all for today. Now it's time for the questions for last time. Question time. And we can close this. Homework is clear, right? No questions? Yeah. Just invite me. Yeah, so if there are no questions, there's a question. What is the difference between the two? Are there some cases? Wait. Yes, everything in the report actually. So the details will be in the repository of the Python beginners. The wiki will link to that. Yep. Yeah, get that page. So tuple. Yeah. So just ask this question about tuples. Yeah. So tuple. So is it correctly that you asking if it's like if I do define a variable AB and do either this or do AB2 and do it like this? Yeah, it's the same, and we can actually check it like this. Yeah, and it's also same as this. No, it's actually not the same. So this is interesting case because 2 equals and is not the same. Because if we do ID of the AB and ID of the AB2 is different. So the is would compare the two objects and they are not the same. But the value of the AB and AB2 is the same. So 2 equals work. Yes. It's a syntactic sugar. And I forgot we didn't explain the ands and ors. Yeah, but that will be in the IPython notebook. It's like you know, if I do if true and true, yeah, that works. But if I do print, and this will not work. I mean, this will work as well. Yeah, because one of them is true, so it gets printed. Yeah, we will get back to it in the next session. So all clear, all clear. Okay, so questions that can be in the whole week. We can answer them in next session, and yeah, anybody else who watched the stream can get back through this. I will probably cut some parts out so it's more viewable, and yeah, next session. Okay, ending the stream.